So let's talk about making predictions with theoretical probabilities. So if we get a probability of a single event, how could we predict if that event then became multiplied, how many times that probability would occur or could multiply? So we're going to start with this spinner, and we have this little prediction to make. It says predict the probability of landing in or on a star if the spinner was spun 40 times. So the first thing we need to do is just what's the basic probability if we spin this spinner one time. We have the spinner. We have 1, 2, 3, 4, 5, 6, 7, 8. We have an 8-sided spinner, and we want to land on the star. Well, three of the sides have stars in them. So the basic probability if we spun the spinner one time is we have a 3 out of 8 probability that we would land on a star. Well, what they want us to do is make a prediction here. We're now going to predict. We're going to predict what's the probability if we spun this thing 40 times that we would land on a star. So I've got my single probability out to the left, 3/8. I'm going to make a new one now. So instead of, they want us to predict now what happens if we spin this thing 40 times. So kind of like we've done when we've done proportions, this is very, very similar to that. I can actually find a relationship between 8 and 40 here, and then just apply that relationship to the top. So 8 does go into 40. It goes in 5 times. 8 times 5 is 40. So whatever we do to the bottom, we can do to the top. Do 5 here, and then 3 times 5 at the top would get me 15. So our prediction would be that 15 times, if we would land on a star. If we spun this thing 40 times, 15 times we would land on a star. It's just a prediction. It's probabilities. It doesn't mean it's going to happen for sure. But it is a way we can use the numbers to make a prediction. So we just found our first probability, found the relationship between what they were asking us to predict, and then just applied that to the numerator side. Let's try another one here. All right, you roll a standard number cube 150 times. Predict how many times you will roll a 3 or a 4. Standard number cube, of course, is a die that we're used to. And we know we have 6 sides. I need to get my basic probability. It's got 6 sides on a standard number cube. Predict how many times you will roll a 3 or a 4. Well, 2 of the sides have either a 3 or a 4. And we could simplify later, but I'm going to go ahead and simplify this down. 2 out of 3, 2 goes into itself. You can simplify this little fraction by 2. 2 goes into itself 1 time, and 2 goes into 6 3 times. So 1/3 of the sides have either a 3 or a 4 on them. All right, we need to make a prediction then. What if we roll this thing 150 times? So now we have 150 here as our denominator, basically, of our new proportion with basically it's a prediction of probabilities. All right, well, let's do like we did the first time, find a relationship. 3 into 150, you can divide it out, but I know if we cover up the 0 right over here, 3 does go into 15, and it goes in 5 times. So if we just uncover that 0, it would be a 50. So 3 times 50 equals 150, whatever we do to the bottom. We do to the top times 50 here. And basically I'm going to get 50 right here as an answer. So we could predict that if we rolled this dice 150 times, that a reasonable prediction would be that 50 times we would land on either a 3 or a 4. So make sure you have the process down. You have a space for it on your notes page, but the first step we always do is we find the probability of the one event. On the spinner, we had a 3 out of 8 chance of landing on that spinner the first time, or we roll the dice, it was a 2 out of 6 chance, whatever it is, you need to find the probability of your first event. B, sorry, it kind of came in together here, but B, you want to find the relationship between this single event and the predicted number of events. So in the case of the die, we had 2 out of 6 times, which we turned into 1/3. You could land on 3 or 4. Well, then they wanted us to predict for 150 here. Okay? Actually take away the equal sign. But then what I'm saying here is we want to find the relationship. That's this part right here. Find the relationship. 3 goes into 150 50 times. We found the relationship. Finally, C, you apply the relationship, which it's mostly multiplication, but you could get division if it got smaller, to the original single event probability. Um, so that would be when we went up top here, we multiplied by 50, C right over there. So this is the process we'll use ABC each and every time, try to make sure we solve accurately to predict these probabilities. Last practice real quick, got it at the bottom of the page. You're welcome to try it and kind of work ahead of me and see how you do, but predict how many times you will roll a number less than 5 if you roll a standard number cube 250 times. All right, well, back to step A. Had it right here, step A. Find the probability of one event. Rolling this cube one time, what's the probability? We know it has 6 sides, and number less than 5. So how many of them are less than 5? Well, 4, 3, 2, and 1 are all less than 5. So I have 4 numbers that are less than 5. And again, I'm going to go ahead and simplify this early on because 2 goes into both of these numbers. So when I simplify, 2 goes into 4 twice. 2 goes into 6 3 times. So 2/3 of the numbers essentially have a number less than 5. And so now, if we rolled this thing 250 times, step B, find the relationship between the single event and the predicted number of events. Well, if we predicted 250 rolls, what is the relationship between 3 and 250? Let's see. Might not be even right here. So if we got it, 250, if we can't find something easy, I'll just divide it. 3 does not go into 2. 3 goes into 25 8 times. You get 24. Bring down the 0 to get 10. 3 goes into 10. Get 3 times 9. And we're basically going to get a repeat here as we start bringing this down. So we're going to get like about 83.3 repeating as we go. So I'm just going to put 83.3. So we're just making a prediction. So it's okay that we don't have a big round answer over here. So whatever you do to the bottom, we're going to do to the top. We're going to multiply by 83.3. So I'll do 83.3 times 2, which is just what we're doing at the top right here, if you'll remember. And we'll multiply this thing out. Like to move the decimal over one place right there just to make sure we stay organized. 2 times 3 is 6, 2 times 3 is 6, and 2 times 8 is 16. Bring my decimal back one place, and I should basically predict that either 166.6, or what we would basically say is 167, if you'll see me rounding that up a little bit because of the 6, we're going to go up. Basically 167 times we could predict that we would land on a number that is less than 5. So just found that relationship at the bottom and applied it to the top. Don't expect it to always be clean and neat. Doesn't have to be. You can get a decimal in there, but if you're making a prediction, you don't have to get a decimal in there. You can round it up. You can round down if you need to. Thank you for watching.